This is problem 105 from chapter 3. In this problem, we're told that 1 gram of water requires 2.44 kilojoules of energy in order to evaporate from the surface of the skin. It's an endothermic process, so the water is absorbing energy from the skin in order to ultimately to cool the skin. The energy leaves the skin, goes into the water, which then lowers the temperature of the skin. We're told in this problem that we want to reduce the body temperature by 0.5 degrees Celsius. We're told the mass of the body is 95 kilograms, and we're given its specific heat capacity of 4.0 joules per gram degrees Celsius. So with that information, we can calculate the amount of energy required for that temperature change. So we can calculate the energy change by using Q equals mc delta T. We're going to use the mass of the body converted to grams. We're going to use the specific heat of the body in joules per gram degrees Celsius, and we're going to use the temperature change of the body. Now this heat is going from the skin into the water, which is what's giving the water enough energy to evaporate. We're going to cancel out the units because we're paying attention to make sure that all of our units line up before we calculate. And when we calculate this, we get 1.9 times 10 to the 5th joules, which is 190 kilojoules of energy required. Now I converted that to kilojoules because I'm looking ahead in the problem, and I know that I need to find out the mass of water. And I know that 1 gram of water requires 2.44 kilojoules of energy to evaporate. So I know that to reduce the body temperature by 0.5 degrees Celsius, we needed 190 kilojoules. So I'm going to multiply that ratio by 190 kilojoules, and that is going to give the overall answer in terms of mass of water, here rounded to 2 significant figures, of 78 grams of H2O.